Scheduling projects. Project 2, scheduling and duration. Scheduling begins with a critical path, and we're going to look at two methods to find the critical path. The two-pass method and the enumeration method. The two-pass method looks at slack, and the enumeration method picks the longest path. The first thing we do with the two-pass method is the forward pass. First, we have to schedule our tasks. Identify what has to happen. Make a list. No particular order is necessary. Then take your list and put it on a small piece of paper, or post-its, or just imagine it. Once you've done that, come up with a duration for each task. Use your previous experience, call in your SMEs, or some other method. Now we put the task in some type of order, a logical sequence. We're going to come up with 4 dates for each task, each activity. Early start, early finish, late finish. This will allow us to see how much time we're going to have in between tasks and if there's any slack or float. We're going to set up our table moving from left to right. We've assigned letters to each box for brevity. We'll begin here. Early finish equals early start. Now we can't start any earlier than our first task. And so we have no early start. We add 5 days to it, and the task will finish, early finish, on day 5. That means the next task will start on day 5. So early start will be day 5. It'll take 10 days to do it. It'll end on day 15. It's early finish. The next task will start on day 15, take 30 days to complete, and will end early finish on day 45. Task E will start on tab 15, take 10 days, and go to day 25. Task B will start on day 5. An early start is the same as an early finish. Take 20 days to complete, end on day 25. Task C will start on day 25, take 10 days to complete, and end on day 35. Now we have 3 early finish dates: day 35, day 25, and day 45. Now to set the last task, we're going to choose the latest date or the biggest date. So we start at day 45, take 25 days to do it, and we end on day 70. End of the first pass. The second pass starts from the other side. We move from right to left. And in this case, late start equals late finish. And we begin with the last task. We take the end date, 70 minus 25, gives us 45 days. And so our late start will be 45 days. And each of the tasks that precede it will have a late finish of 45 days. Late start equals late finish. Task E, late 45 minus 10, a late start of 35 days. Task F, a 45 minus 30 is 15. So 15 is our late start. Between the two, we're going to choose the smaller this time. Task D, our late finish is 15 days minus 10 days work, gives us 5 days for a late start. And you can see how we do the rest of these. We now have completed the early start and late start times. In some activities, the early and late starts are the same. That means they have no slack. There's no float. In some activities, they're different. That means that we can start them earlier or later depending on scheduling and availability of resources. The path with no float is the critical path. Now, the two-path method calculates slack. The critical path is the one with no float. The two-pass method shows float out on the side, and you can see that now each box has a float number. Either no float, a high of 20 float on task E. The 10-day float means that we can start this activity as early as day 5 or as late as day 15 and still allow task C to begin on time. Simpler than the two-pass method. The enumeration method looks at each path, each possible path. ABCG is 60 days. ADEG is 50 days. ADFG is 70 days. The longest path is the critical path. Now, a schedule is no better than its duration estimates. And I'm going to show you a technique for estimating the duration. It's part of the PERT, and the PERT stands for Program Evaluation Review Technique, finding duration. And so we sequence our activities into a network, which we've done. Then we create 3 estimates of time to complete each activity. Now, estimates are based on whatever you want. I've chosen optimistic, most likely, and pessimistic. And we assign a weight to each estimate. In this case, the optimistic and pessimistic are worth 1/6, and the most likely 4/6, or 2/3. Add those together, we get the expected duration. On this chart, we have a list of activities on the left side, and then 3 different looks at duration. The optimistic look, the most likely look, and the pessimistic look. And when we do the math, we get the expected look. A little closer look at this. If we took the optimistic look of 4 times 1/6 equals 0.667. The most likely 5 times 4/6, 3.33. The pessimistic 12 times 1/6 equals 2. Add them all together, and it comes out right at 6. I think you're ready for Project 2, Scheduling Duration. Thanks for watching.